Hello everyone, welcome to this class. In this class, we are going to deal with subsets. First thing we are going to check is what is subset. Subsets only occur when a set, like the whole content of a set, is also the content of another set. Let's say we have something like set A, and set A has 1, 2, 3, and we also have set B. Set B has 1 and 3. So you can see the whole content of set B is in set A. So in that case, you can see set B is a subset. This is a symbol, not C, kind of long C, is a subset of A. So that's what we are done with subset. At the same time, we also have that A contains C, because set B is a subset of A. A contains C. So we've done with these two symbols. Are we together? Let's say we have, let me say we have another set C, and set C is 4, for instance. What do you notice? You notice that, okay, let's also add, okay, set C should be 2. Let's call it 2. What do you observe? You observe that set C is also a subset of set A, but set C and set B, they don't contain anything. In that case, you can say that set C is not a subset of set A. Are we together? Because both of them does not have same thing in common. Another way you can also look for subset is where you have, let me say, I will say have 2 and 4 here. You can also say set C is not a subset of A, even if set B contains what set A has, but one thing is not the same. In that case, you can say they are not subsets. But in this case, you can notice that set A has, so set A contains set B, and at the same time set A contains set A and set C. You can now see that set A is the universal set. The universal set is the set that has all the whole subsets in question. Once you are going to know that an empty set is also a subset of any set at all, but in this case we are talking about an empty set is also a subset of set A. And also know that set A is also a subset of itself, a universal set. You understand? In that case, we've done this empty set. Proper set are things like this: a set that is a subset of another set, but it's not an empty set or a universal set. Those are the ones we call the proper sets. So knowing all these things, let's solve the examples. Let me recap before we continue. A subset simply means when a set, the whole element of a set, is contained in another set. Universal set is a set that contains all the subsets. You can have as many as possible, but universal set is that set that has all the whole subset inside of it. While an empty set, well, we did in our previous class, this is the notation for an empty set, or you can just draw a set that has nothing inside. It's a subset of the universal set. Also, universal set is a subset of itself, but a subset that is not an empty set or a universal set is called a proper set. This is the element to denote that something is a subset, and this element to denote that something contains another one, and this element is the same, but I mean to say to denote that a set is not a subset of another set. So first example, given U is A, B, C, D, E, F, G, H, I, J, and C is letters of the word cabbage, and V is a vowel sound, and H is the word, is letters of the word heat. First, we have been told to list the members of V and what? C. So let's go for set V. There's something I want to make clear. When you are dealing with a subset and you're being given the universal set, this is universal set, this symbol for universal set, and then you are given the subsets. Remember what we said here, the universal set is the set that contains all the whole subsets. So make sure that when you are creating the subset, it must be an element in the universal set. We all know that when you are being told that the vowel sound, what makes up a vowel sound in English alphabet is E, I think I, O, U, I think I omitted E. So E. These are the five vowel, these five vowels we have in the English language alphabet. But in this case, make sure that you are picking only the ones that are in the universal set. Let's not make that mistake. So the element of V is, we have A here. Okay, also have A in the universal set, so A will be there. We have I is there, so I will be there. We have O is not in the universal set, so E is there. I think E is supposed to come first, but nevertheless, the arrangement of set does not matter. So this is the element of V. I know a lot of us might make the mistake of listing out all the whole vowel sounds, or the whole vowel. I don't know how I mention sound. So make sure that whenever you are giving a universal set and you are giving ideas in the subset, let the subset be an element of the universal set. Don't forget. So the next we are being told the element of C. C letters of the word cabbage. So let's go. We have A here. Okay, no, just have C. C is in the universal set, so C will be there. A is in the universal set, so A will be there. B is the universal set, so B will be there. Mind you, remember in set, repetition is counted as 1. So don't repeat this B and don't repeat this A, is okay. G is there, while E is also there. So when you are being told to list out the members means elements that makes up the set. So this is what we have: 1, 2, 3, 4, 5. So this is your first answer. Then the second question says draw a Venn diagram showing VC V U V C H. So this is how we draw a Venn diagram. Let's say we have the universal set as a square or a rectangle. In my case, anyone is okay. And what's the symbol for universal set, which is U? I'll put U here. First, we have H. H is the what? Letters of the word heed. So let's check. H is here, I is here, D is here. So this is H. H is what? HID. Maybe I'll have to write it out. H is HID. So that we know what we are doing. So the next thing we're going to do is, let's draw for C. This is my C. I'll first draw the first circle. The next one is V. But before we go, there are some things we need to note. Let's check for the intersections of these subsets. So what does V has in common with H and C? So if you check, V has I in common, so we can say V intersection H is I. So what does C has in common with H? If you check, they don't have anything in common. But what does C has in common with V? You can see that V has A and E in common. So you can say V intersection C is what? A and E. Though we've not done intersection in this class, we'll still. But intersection means what both sets have in common. So having this in mind, the next thing we're going to do is, okay, let me call this my C. This is my C. So I know that C and V has something in common, while V and H has something in common. In that case, I can just draw it like this and draw this one like this. So this one is C, this one is V, this one is H. So you can see C and H has nothing in common, but V has something in common with C and has something in common with H. So the first thing you're going to do is, what does V has in common with C? A and E. At the same time, what does V has in common with H, which is I? So make sure that C as a circle contains everything that C has. Now we've taken care of what they have in intersection. The remaining ones will be on its own. So those ones will now be C is not here, so I can write C. A is already here, no need. B is not here, I can write B. G is not here, I can write G. E is already here. So if you look at C as a circle, you see that it contains everything that you have here. Coming to V, looking at V, we've already taken care of A and E. At this intersection point, we've taken care of I. And V is only 3, so there is nothing we can put here that is on its own. So make sure that the circle contains everything that is in the set. Don't come and write the intersection and still come and repeat it here. You are repeating the members, which does not make sense. So in the case of H, we have H because it's not, and what? D. So by the time you look at it, you see that H as a circle has everything that we have in the set. So the main thing is we've drawn the Venn diagram, but remember when you're drawing the Venn diagram, you're considering the universal set. This is the universal set, right? So let's go back to the universal set. A has been taken care of in this whole illustration. B, excuse me, has been taken care of. C has taken care of. D has taken care of. E has taken care of. F. By the time you look for the F is 9 there, so I'll write that F here. G has been taken care of. H has been taken care of. I has been taken care of. J. If you look at, there is no J in this whole illustration, so you can write J. So this is our final Venn diagram. What do you observe from this diagram? You observe that this is a universal set. So if you look at U as a universal set, everything that is inside it, this square, you can use a square, you can use a circle. I'm using a square in my own, is inside this set. Looking at C as a circle, everything that is inside the circle is what you have in the set. Looking at V as a circle, everything is what we have in the V. And looking at H, everything in circle is what they have. Then make sure that the intersection points correspond. You cannot just put name here H and name here V. At the end of the day, you're intersecting A and E. No, it must correspond to what is happening in the set. So let's solve another example. So this is exercise 5D number 10. We have universal set 1, 2, 3. Remember in our previous class said that this dot 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 is used to represent things we don't want to write out. So if you see the pattern, you can know that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. This is what is here. Then N stands for what? Even numbers. So let me write out the element of N. Remember, even numbers are infinite sets. But because we are dealing with universal set, we are being told that this is our universal set. You will be told, don't just apply it. You will be told that okay, this is universal set. So the whole subset, make sure that they are also subset of the universal set. So if you are told even numbers, make sure that you are only considering the even numbers that are subsets of this universal set. So in that case, you have 2, 4, 6, 8, and 10. That's for N. Okay, I think this is not showing in my slide. So let me write it out. N is even number, which is 2, 4, 6, 8, and 10. So this is your N. Then the next one we are going to look for is F, which is a number divisible by 5. So the number divisible by 5 also is an infinite set, but because we are dealing with this case of universal set, make sure that it is a subset. So in this 1, 2, 3, 4 to 10, which are the numbers divisible by 5? There are only two numbers, which is 5 and 10. So your F will be numbers divisible by 5, which are 5 and 10. The next one is G, which is numbers greater than 3. At the same time, numbers greater than 3 are what? Numbers greater than 3 are infinite set because it's from 4 upwards. But we are only considering the ones that will be members of this set. Are we together? So in that case, let's consider set G. I'm going to squeeze it here as 4, 5, dot, dot, 10. So this my dot, dot represents 6, 7, 8, 9, and 10. These are the numbers what greater than 3. So let's start solving. First thing is, write down the following statement using the symbol 5 and 10 are both greater than 3. So in this case, if you are to solve it with our set, any element of set G is greater than 3. So simply all you need to do is say that 5 is an element of set G and 10 is also an element of set G. So we can say 5 elements of G, that's a symbol of element, and this is a symbol for and, 10 elements of G using the set notation. So this is our answer for the first one. For the second one, if A is a number such that A is element of N, A is element of G, A is element of F, and A is element of the universal set E. Kind of, this is not E, but is kind of close to E. What is A? So what they're trying to say is to find a number that intersects across these 5 sets N. Okay, sorry. Universal set N, F, and G. So what are the common thing here? So let's check. First, this is universal set 1 to 10, and we know that 1, 2, 3 is not even a set G, so these ones are out. So we'll look for a number that this have, this have, this have, and that have. So the first number I'm seeing that both the whole of these 4 sets have is 10, I think. N has 10, F has 10, G has 10, and universal set also have 10. No other number, no other number. I'm just checking, no other number. So the answer is, in this case, is what? 10. A is equal to what? 10. The next one, where if B is a number such that B is element of N and B is not element of G, what is the value of B? So we are dealing with N and G. So let's check for the numbers that are in N but they are not in G. It's called disjointed sets that are not intersecting each other. So let's call B as a set, and so let's start selecting a number that is element of N but not element of G. This is N. 2 is 2 in G? No. So wait, if B is a number that is element of N but not element of G, 2 is 2 in G? No. So we'll put first element 2. So the next one you're going to look for is 4. Is 4 in G? Yes. 6. The remaining ones are all in G. They are all in G. So I think the answer is just 2. But we have been asked if B is a number. So as a number, the answer is just 2. We're not expressing it as a set. So this is the answer. So number D says, draw a Venn diagram showing universal sets N, F, and G. Now I have to write everything here because we're on another page. This is universal set 1 to 10. This is N, 2, 4, 6, 8, 10. This is F, 5 and 10. And this is G, the odd number greater than 3, 4, 5, 6, 7, 8, 9, 10. So first we draw a square or circle, which any shape you prefer is okay. Just make sure you get the whole point, which is the universal set. Let me just call it universal set. First, we will now have N, we have G, and we also have the universal set. So let's draw. We already know we are dealing with 3 circles in this case. We have another circle here. Also have another circle here. Now, what does the 3 of them has in common? They have 10 in common. So just put 10 here. F and G has 5 in common and also have 10 in common, although the 10 has been taken care of here. So let me call this F and call this G. So what F and G have in common is 10, sorry, 5, 5, 5. So I'll put 5 here. Mind you, if you want to deal with this, you have to deal with the intersections first before you come up and write the remaining elements, elements of the set. If you do not do it that way, you might make a mistake. So that's why I started with the one that three of them have in common. Now I'm dealing with the one that two has in common. The next thing, I will learn that this F, this is G, this will now be N. What does N and G has in common? This N and this G. They have 6, 8, and 10, right? 6, 8, and 10. So N and G, I will now write 6, 8. Okay, 10 has been taken care of here. Excuse me. What does N and F have in common? N and F, they have no other thing in common apart from the 10, which they already have. So here we don't have anything. So now we've taken care of the inside. Now we can now fill up the remaining ones. N has 6, 8, 10. So the remaining one, 2, 4. The 6, 8, 10 is already here. G has 4. 4 is not here, so we can put it. 5 is already here. 6 is already here. 7 is not here, so we can put it. 8 is already here. 9 is not here, so we can put it. 10 is already here. Then F has 5 and 10. 5 and 10. So there is nothing we can put here any longer. So this is a Venn diagram showing this whole element. So I hope with this class you're able to understand the concept of subsets and how to express set in Venn diagram. Thank you. Any question, you can leave it in the comment section. See you in the next class.